got to make the argument here just because I've spent some time on this one because I've been asked this question a lot is, what is 25 ohms? Why is 25 ohms the value? And it is an illusion to 25 ohms if a single electrode is driven. So that's NEC 250.52, if I recall correctly, 52 or 54. I'm not Mike Holt, as you can tell. So single ground electrode, 25 ohms or less. Two ground electrodes installed at least 6 feet apart, which we know that, and the NEC acknowledges this, the paralleling efficiency of electrodes can be greater if we put more space in between those electrodes, but they say 6 ohm or 6 foot minimum spacing between those electrodes. The number, it does not state that we need to retest. So 25 ohms or less on a single electrode, or just install 2 electrodes. What do we see for general purpose grounding? We see 2 electrodes installed, right? Now the NESC, as you mentioned, does have a specification in there, but it is somewhat similar. So we know that 25 ohms and the origin of 25 ohms, and I'm not going to be exactly correct on this because I don't know that this is exactly the right answer. However, it's from telegraph. So we're talking about something, and there's a coincidence there that with telegraphs, we knew that if we could get to, I believe it was a 50 ohm resistance, but we were in series with each other. So we were doing just a, referred to as a dead earth test, where we are essentially doing continuity through the soil. We would eliminate or minimize common mode voltages. We wouldn't have noise on the line. So we're talking about something that's very, very old there, in its reference. I know from traveling all around the country and the world now, doing soil resistivity and fault potential measurements in, like, for instance, the Pacific Northwest, especially as you get closer to the coast, 25 ohms is an illusion to think that you're going to get that with 2 electrodes. It's just not going to happen in most of those locations because they're either heavily rocky or they have very poor soil, or both in many cases. So it's very dependent on where you're at and what you're going to produce value to value, but be aware that 25 ohms is kind of just a made up value. I'll add to Tom's comments though about what's a good and a bad value. I never like to engage in this conversation because we're on the testing side of things. I can tell you what it is and how I can guarantee you that this value is accurate. But Tom mentioned earlier, we're going to be considerate of the environment. This is an apparent measurement. And I think that's important to nail down. It's apparent because it's today at 3 p.m. Today at 6 p.m. it rained. So now the value is going to be different, right? Or in 6 months it was drier, or whatever the case may be, right? The soil gets disturbed, whatever. We mentioned all these different variables that can affect it. So we want to be conscientious that this is an apparent value and it's going to change. And that's true with most of the testing that is going to be done by the group of viewers that would take a look at this. But it's going to be more extreme with ground resistance measurements. Gotcha. They're going to change quite a bit. So, just be aware that these values and how they're laid out or what their specifications are can be, they can come from all over the place. IEEE 142 is going to say 5 ohms or less. Like they're just going to say 5 ohms or less, period. And they may specify even lower than that. Specifications, though, from manufacturers are really what drive a lot of very low resistances. So Motorola, for instance, like we mentioned earlier, is going to classify different sites for what their intended purposes, class B, class A, so on and so forth. They have to have different resistances because they are either critical or less critical or non-critical in that case. Lightning protection systems can have different values depending on where they're located. We're looking at what kind of system was installed, what the flash density is of that location, and does it need to have a 1 ohm or a 5 ohm or a 25 ohm resistance value, oftentimes specified as being 5 ohms or less. So these values here, I never like to engage in this argument. What's better? Lower, period. Always. It's a golf game. If you get to 5 ohms with a single electrode, great. You have a 5 ohm resistance connection to the earth. I think it's important too that we nail this one down as well. We don't just install ground electrodes to get to a low resistance connection. Tom kind of alluded to this earlier. Just because I have 5 ohms on one over here in let's say the northeast corner, doesn't mean that I don't need more electrodes, because I'm also controlling voltages in the earth.
Right.
right? So I have those shells that we described earlier. I like zones better, tell me that if I can have these potentials that are created, on, different ends of my installation or whatever the case may be. So we don't just ground just specifically to our, we don't, I guess we just don't ground just specifically to limit voltage in one location to have a 5 ohm resistance to earth. We need that system to be, to control the earth voltages to minimize those, gradients that are created when we do have a fault condition, overall. So, just, there's again a lot of nuance here on the values. I think that for this, topic of conversation, let's leave that to the guys writing the specification, the standards, whatever it may be. That's what's critical. How we produce the value, how we know that the value is accurate, and what the extenuating circumstances of those values are critical, for this conversation. Rainfall, what the soil type is. I'll mention a quick trick on that. The USGS maintains a ton of data on that, and it's all free. There's a map that you can get on their website, and you can, pinpoint the location that you were testing at to see what the soil constituents are. That's not going to be an exact example, but it's good enough in most cases to notate what kind of soil you were testing in. You mentioned temperature and all that kind of stuff. I think rainfall is the most critical one that we can notate there. But the direction in which we set out our test probes, because that's one of those variables that I can constrain. I can control that for future testing. If I tested in the northeast corner this time, I'm going to perform the test again in the northeast corner. Was the system isolated or not? Sometimes we see this testing prescribed on systems that are not isolated. This shows up in a lot of lightning protection systems. They're not going to de-energize. They're not going to isolate the system because it's either impractical or impossible to do so. They're going to repeat the test the same exact way over and over again. Is that truly the resistance to ground? Absolutely not. But by repeating the test over and over again, we can at least establish some repetitive values that we can trend over time. So, understanding why the test is being done and the spirit of which the test is being done is, I think, critical as well too.